Greetings, my name is Matthew Garcia, and on behalf of Group RF8, we will be discussing and analyzing Chapter 7's case of Circuit Board Fabricators Incorporated. Let's begin.
Hi, my name is Andrea Del Valle, and starting with the introduction, Circuit Board Fabricators Inc. is a manufacturer of circuit boards located near San Jose, California. They are known for doing business with renowned companies such as Apple Computers and HP. Apple Computers and HP use the circuit boards as prototypes for making their new products. Circuit Board Fabricators produces their circuit boards through an automated process to be able to give a quick and high quality service. However, in recent years, the company has experienced a lot of monetary losses.
Hello, my name is Taimi Silvera. I will be presenting the thesis statement. CBF uses a batch flow process, which is a process used by manufacturers to create a product through a series of workstations, starting from one stage or step until reaching the very last one. In this case, the batch shop flow process is being used to create electronic boards. This method is being used because they have a solid line of circuit boards, and we will be touching base on what needs to be done or changed to achieve the production of 1,000 boards per day. Based on the information provided, along with the diagram which we will be using as a guide and a path that itemizes information required to complete the sort of equipment and operations, our analysis will address the process flow structure, design a process flow chart to identify and eliminate or reduce activities that make the process slower, analyzing the capacity of the process, impact of losses, short and long-term solutions, and recommendations for improvement opportunities. Our main objective is to come up with ways to offer a production of quality circuit boards, which are the key goal for the benefit of the company as well as for customer gratification and satisfaction.
Hello, my name is Paulina Zuluaga. When talking about the process flow structure of the company, they have a job shop process flow structure. So this type of flow structure is used for a production of small batches of a large number of various products similar to the circuit board. So there's a lot of very different parts, but there's like small amounts of it because the circuit boards are so complex. And so this flow structure allows for flexible operation, and that way several activities can go through it and can pass quicker. And when we take a look at the diagram of the process, we start with order acceptance, then it moves on to machine programming, and then it goes to the board fabrication. And from there, you have the load machine, which takes 5 minutes, and then there's a setup of 0.33 minutes per part. Then the cleaning, which is 0.5 minutes per part. Then the coating, which is 0.5 minutes per part. Then you unload, 0.33 minutes per part. Then it's the expose. So then you have 15 minutes. Then you have a setup of 1.72 minutes per part. Then again, you load the machine, 5 minutes setup, 0.33 minutes per part. Then we develop, 0.33 minutes per part. You inspect, 0.5 minutes per part. You bake, 0.33 minutes per part. And then you unload, 0.33 minutes per part. Then you do the drilling, 15 minutes setup, 1.5 minutes per part. The copper plate, 15 minutes setup, 1.5 minutes per part. And then finally, you do the final test. You make sure everything's going well, everything works, everything's perfect and in order, which takes 15 minutes. The setup, and then 2.69 minutes per part. And then last but not least, once everything's checked, once everything's done and you've gone through the whole process, you ship it off to the customer.
Here, we will be analyzing the capacity of Circuit Board Fabricator Incorporated's manufacturing process. With the use of numerically controlled equipment and computer-aided design, Circuit Board Fabricators, or CBF for short, has automated much of the manufacturing process. Because of this, CBF has high expectations when it comes to their output. CBF expects to manufacture 1,000 boards per day on a 5-day work week consisting of one 8-hour shift. To put this into perspective, they need to receive and produce more than 125 boards every hour. That is why they are only able to produce 700 boards on a good workday. It might seem impossible to reach 1,000 boards per day, but it isn't. When you calculate the capacity utilization rate, you can see it is possible. The capacity utilization rate levels give insight into the overall slack that is in the economy, or in this case, a firm, at any given point. The formula for capacity utilization rate is actual output divided by potential output times 100. As you can see, we did this for CBF. We have 700 divided by 1,000, which equals 0.70. You get that number and you turn it into a percentage, which equals 70%. This 70% means that there's 30% in the company that can be improved on, because 100% has not been met. 100% of the utilization rate cannot be met because of the 20% of the boards that are being rejected. Because of this rejection rate, CBF has to increase their desired output by 25%. So instead of 1,000, they need to start aiming for 1,250 boards a week. Slack is also noticeable on the work hours per week. Although they are expecting to work 8 hours a day, they do not. 30 minutes is given for lunch, and each employee is given 2 15-minute breaks as well. When this is added up with the 60-minute total machine setup time, CBF has 2 hours unaccounted for. With only 6 hours of production time and the 25% increase of boards, CBF would need to produce more than 208 boards per hour. If you subtract 125, which was the original expectations, from 208, this is 83 more boards per hour that need to be produced. This goes to show that CBF is in dire need of assistance and entire reevaluation of the manufacturing process.
Impact of losses. The impact of losses in the system is very, very substantial. CBF created a strategy to expand the size of an order to yield to rejected boards. The firm has to allocate their production because there may be issues in the process, which causes some boards to be rejected. It is specified in the problem that 15% of the boards are predicted to be rejected during an early processing examination, along with an additional 5% rejected during the final testing. This results in a total of 20% rejection, failing rate that happens during the process. By way of explanation, for every 1,000 boards manufactured, there will be 200 that will be defective. In order for CBF to fulfill the 1,000 boards order daily, at least 120% of their orders should, because during this process 20% of the boards that went into production will get rejected. In the event that an average shop size is 6,000 boards instead of 1,000, this means that the production should actually equal 7,200, since it's required to start at 120% minimum to meet the average job size, while 1,200 boards that represent the 20% of the same production are estimated to be rejected. And after the whole manufacturing process is completed, CBF will end up with 6,000 boards that have all passed the tests and inspections.
As mentioned before, CBF faces a big problem with their expectations not being possible because of a variety of factors. However, the biggest factor is time management. CBF needs to maximize their output in the amount of time they have, in the small amount of time they have, should I say. As mentioned before, when all breaks are excluded, employees only work 7 hours a day, not including the 60-minute setup time. As a short-term solution, CBF should try to minimize or eliminate as many of the steps in the process as possible. However, all the steps in the process are essential, so what should we do? CBF should look to eliminate, or complete, should I say, the first steps in the process of load, clean, coat, and unload before an order is placed. This would allow CBF to have a work-in-process inventory at all times before the expose step. CBF can also look to adjust employees' work schedule by eliminating the 2 15-minute breaks and allowing some employees to work overtime. Although this might seem unfair to some employees, this would serve as a very short-term solution until a long-term solution comes into play. For long-term solutions, CBF has quite a few problems to fix, and even with our short-term solutions, we actually created more problems as well. The problem that we created with our short-term solutions was that employees would be working more hours and working overtime. Because of this, we feel CBF should look to automate more of their manufacturing process. The most time-consuming and physically demanding steps in the process are the loading and unloading step. This is why CBF should speed up the unloading process and take away the physical labor by automating these steps. To be more specific, CBF should look to partner themselves with a company that specializes in automated loading and unloading systems, such as Gelada Hydro Loading Technology and Automated Concepts Incorporated. Using their technology systems would improve the overall process, consistently run speeds with no breaks, shift changes, or rehires. It would also reduce costs and product damage. This would act as a domino effect, as reducing product damage would thus reduce the rejection rate, meaning CBF would not have to produce as many boards as they had to before. As for the employees that previously loaded and unloaded, they would be moved to quality check, lessening their workload. With quality check in each of the steps, this would allow CBF to narrow in on what is causing the boards to be rejected and fix that said problem. With that said, CBF could also look to hire a third-party training company, such as Six Sigma, which would analyze each step for them. However, this might be too costly and too consignment for CBF, but that is up to them and their final decision. To summarize, we learned that CBF uses a job shop process flow structure, which is used for the production of small batches of a large number of various products, in this case, circuit boards. With that said, it is clear to see that the manufacturing process is faulty, as CBS falls short of their high expectations. This is evident through their capacity utilization rate. What should be done then? Well, we feel that the best plan of action would be to complete the first steps ahead of an order, as previously mentioned. This would create the work in process inventory that we would need. Perhaps they could even purchase the parts already completed. Afterwards, it is essential that CBF automate their loading and unloading steps in the manufacturing process. Particularly, we suggest partnering with a specialist in this area to avoid the time and the cost it would take to build the process on their own. Although costly at first to partner with a company, with the increased output, reduced costs, and reduced damages, CBF will turn a profit very quickly, and that is something we are sure of. Hello again, my name is Matthew Garcia, and on behalf of Group RFA, we would like to thank you for taking the time to watch this video. We hope you learned, we hope you enjoyed it, and we hope you have a great rest of the day. Bye-bye.